next one is a word problem. So the word problem is this baseball problem where the ball hits the bat. So that's the end of the bat. Here's the ball. Hits the bat. Comes off the bat at an angle of theta. And the ball's exit velocity in this particular version of the problem is, I think it was 80 feet per second. And then that's v sub 0. And then the distance that the ball travels before the outfielder, I assume, catches the ball, maybe it's not outfield, like it's only 106 feet in this particular case, is 106 feet. And then they give you this equation. R equals 1 over 32 v sub 0 squared times the sine of 2 theta. So this distance, how far it's going to travel, is based on the angle it departs off the bat and its initial velocity. So that's why, if you're familiar with baseball or softball, the faster the pitch, the farther the ball has the possibility of going, because it'll come off the bat faster if it's struck in a solid way, etc., etc., etc. So yes, there's physics in baseball. I think that was an obvious statement, yes. So now I'm going to substitute these values over there into the equation, and so we get 106 feet equals 1 over 32 times 80 feet per second squared times the sine of 2 theta. And what we're looking for is to solve for that angle. What was the angle off the bat? And so we take 106, take 80 squared, which I think is, well, it doesn't matter. I'm going to multiply both sides by 32. So I'm going to get that. And then I'm going to divide both sides by 80 squared. So 32 times 106 divided by 80 squared is equal to sine of 2 theta. I'm going to put all of this in my calculator and get some value. Times 106 divided by 80 times 80. That's better. So 0.496875. 0.496875. 0.496875 equals the sine of 2 theta. I'm going to take the inverse sine of both sides. .496875 equals, and I'm going to get 2 theta is equal to, that one's weird, but it's still, I guess that's all right. So I'm going to take the inverse sine, the function's over here, inverse sine of 0.496875, and it's 0.51 radians, it looks like. Yep, but that's 0.5199 radians, 5911 radians, which then, if I divide both sides by 2, I'm going to get an angle measure of 0. I wrote this wrong. It should be 5199. And so when I go 5199, this is going to equal this. Poop. 0.519940799602 divided by 2. And I get 25.2599, 2599, dot, dot, dot. And that is going to be equal to how many degrees if we really wanted it in degrees. I don't know if they did or not. So 0.25 radians to degrees, I'm going to have to multiply times 180 and divide both sides by pi. And that number in front there is going to be 2.25999,703,9801. And so I get 14.8967 degrees. So we get, if we convert this to radians, we get 14.8967 degrees. Okay? And that's what we get as an answer.